Hello everyone, Krasimir here with another FumeFX tutorial. This time we are going to create this amazing explosion by just using the FumeFX 6 and nothing else. I will also show you how to create this cinematic shading by using the FumeFX Explosion Preprocess option and using the Arnold standard volume shader. If you like new FumeFX and you consider purchasing a license, make sure to visit our online store. Don't forget to subscribe to our YouTube channel as we will publish tutorials on a regular basis. We will start explosion setup using NodeWorks particles. As you can see here we have two boxes, data center for our explosions. Those explosions are timed 4 frames apart and each one lasts for 6 frames. We use Explosion Gen node to generate those patterns, and the first blast is a little bit closer to the camera. It precedes the main explosion that is beyond, a little bit further from the camera, has a little bit more spikes, more dense particles, and moves faster. So the Explosion Gen we have cluster by spike, which means all the particles within the same spike will belong to the same cluster and have the same cluster ID. As you can see here we have color set by cluster, and we use this cluster ID to initiate the random number generator by using the seed connection. This means that all the particles within the same spike will generate the same output value. So each particle within a spike will have the same temperature and each random color that we assign here, and move to the set particle attribute as a color and the custom channel temperature that is set here as a float. As I said before, times of the explosion, it starts at frame 0, duration of 6, this is actually particle life. Speed, it's moving 150 units per second, and it goes in the upward direction. And this direction variation gives us actually the spread of the explosion. If we use a little bit higher angle, for example like 180, you will get something like area explosion, and a small angle will create some very strong burst in the upward direction. I'm using the 90, number of spikes is set to 20. This count variation doesn't apply to this one explosion blast. It's used the same way as the speed variation. If we have different explosions, which means different inputs, like for example if you have particle group and you want each particle to create its own blast, then you would use particle position for each particle in a group with these variations. As I said, this number of spikes is set to 20 and directional bias is 0. With directional bias of 1, we say that we prefer that velocities are the greatest along the explosion direction, and with bias of 0, it's all the same across all the angles. Randomness gives us randomness at the length or the speed of the spikes as you wish, and something like we had at 0.5 is good for this purpose. And particle density determines number of particles within each spike, and this spread is the spread of the spike length. If we shorten this, we'll get some peaks of the spikes that propagate along the explosion duration, and I'm using this one. This is the seed and not using the size and density properties here. And now if I switch here from the color to display cluster to actual color, we can see this color here as we assign those color to particles. So as you can see, particles within the spike have the same color. Similar is for the temperature. The blast 2 is, as I've said, a little bit further blast. It has a little bit darker color scheme than this one. Just to return here, and it creates more dense particles and is going to serve as the main blast. Besides this blast, we have trail particles. They just can generate some particles on the surface, and I move them in the direction that we want. It's custom direction here. A little bit variation to add some spread. You can adjust this to your preferences, and those particles have the lifespan of 100 frames, as we want them to be present throughout this explosion animation. At the end, we have this control tab that adds a little bit more control for all those particles that we have here, as I don't want any of the particles that go beyond this Z plane here to be alive, so we kill all the particles. You can see here that position is below 0. We delete that particle. For all the rest of the particles, we apply some drag, so that goes for those explosion particles as well for those little debris that flies away, and for those trail particles, and only for those, we apply gravity so they behave naturally. And now, before continuing, we are going to cache this setup. So go to caching, set your path, select all the channels because we need custom channel, we need particle shape, so just check everything and hit the export button. And now for the FumeFX setup, as you can see, we already have FumeFX grid here. This is the FumeFX that is going to create the explosion simulation, and here is the tab that is going to apply sources. Now, usually we would create another workspace and create the FumeFX setup in that workspace, as the workspace 1 will be for particles, but for the simplicity I'm going to create everything within the same workspace. Now, since we have those particle cached, we need to load them, but not to use those. So we should disable all those tabs and enable this one. And for this tab state is very useful little node that just can invert the disabled state of the tabs. So right now all those 3 tabs are disabled, non-functional, and we only have the FumeFX tab enabled here, where we get the simulation info. There's the simulation for the workspace, and we get the workspace export path. This is this path here, and we use that path as the input path for the load particle cache node. We have here enabled a single frame, which means that this cache will be loaded only for a single frame, which means if we're scrubbing slider back, usually the simulation should go from the first frame to that particular frame, and all the caches should be loaded. With the single frame enabled, it's going to load just for this particular frame. We use interpolate subframes, for example, if you're rendering with motion blur. And here we have the list of all the channels that are present in our caches. For the simulation, we have the FumeFX simulation reference node, where you pick this FumeFX grid, and then we can use this grid within the grid sources node and all the rest of the FumeFX nodes that we have for the simulation. Then we have the get particle group with the regular expression, which means that we're going to get our blast particles on this output, and all those particles are going to be used as grid sources node. Here we're going to select FumeFX simulation reference. This is the node that references to this FumeFX grid, and all the sources are going to be applied directly to this grid. Now, this is the beauty of the node-based approach, because this grid source can apply smoke, fire, temperature, oxygen, color, motion velocity, custom direction based on all the particles in the scene in relation to other objects, cloth, soft body, whatever you want. You can just create a node network and control what your grid sources are going to emit, how it's going to look. It's incredibly flexible, can create whatever you want. In this tutorial, I'm just going to use to set the temperature that we set here before throughout this Explosion Gen node. As you remember, we set the color and the temperature, so I'm just using those values that are loaded from the cache. I just put from the custom channel temperature to the temperature and set color to emission color here. Enable color, of course, is checked. Enable temperature, enable fire, and enable smoke. For the smoke value, I'm using the position of the particle, and I use the parallel noise with the turbulence noise function. Scale of 1 level, and that's just enough to get some nice detail on the smoke. And I'm using this noise as from output from 0 to 1 and using this to remap from 2 to 3. So the smoke that is going to be emitted will range from 2 to 3. Then we have the trail particles, just the trail particles, and I'm using the age and remap between age 0 to 20 to 0.7 to 0, which means that output value will be 0.7 when the age is 0, which means that a particle birth, and when age reaches 20, this output will be 0. And I'm using a little bit of the math here, power node, that creates just a sharper fall-off of those values, and I'm using this as a grid emission smoke. This is used, as you can see in this video, for the emission of the debris. When debris reaches age of 20, there will be no emission at all. This will conclude our setup for the explosion regarding particles and FumeFX sources. And now we're going to switch to the FumeFX simulations to see what's changed here and what we're using in this case. Each time you press the FumeFX simulation button, it connects with the NodeWorks and pulls all these sources, obstacles, voxel manipulations, as everything is now integrated and everything works together. So it's pretty amazing, right? Now for the FumeFX simulation, let's see what we have here. Of course, we have the adaptive grid. I add a little bit more extra padding to the simulation area, using all the fields for the sensitivity. And take note that this is like production setting, where the simulation grid could go up to 1000 voxels on the X side, but definitely it doesn't reach all this simulation area. It's going to be a little bit smaller. And we're exporting fuel, smoke, temperature, color, and velocity for the motion blur. For the simulation, standard QCG parameters, nothing's changed here, default direction, and we use the vorticity 2 with a strength of 2 and scale 0.02. Now the gravity is default, and what we changed here to add more detail and commotion at the beginning is the turbulence. It's the same along all the axes, and the strength is 2. So our voxel size is 0.2 and this strength is 2, which is pretty strong turbulence that you generally don't want to see throughout all the simulation. So we taper down this value, so you see after 50 frames goes to 0.04 and then fades a little bit further to 0 at the frame 40. So we kill it completely after frame 40 and just leave detail that's added by vorticity. No artificial detail here. Simulate fuel, of course, and what we have here is ignition temperature of 1, which is really low, as we want all the fuel, regardless of the temperature, to burn. And we use the burn rate of 10, which is a moderate value, as we'll see in the viewport shortly. As you can see, the heat production is 0, which means as the fuel burns, it won't add any heat which generates temperature to the grid, so the temperature is very easy to control, as we just added from the sources. And we have some small expansion that will create fuller smoke and that rolling motion. For the smoke, dissipation strength is 0. We don't want anything to dissipate. We added a little bit more higher temperature buoyancy, so that we want the smoke to rise and this explosion a little bit faster. And we dissipate all the temperature. That's why we have increased this threshold, so all the temperature values are dissipated throughout the whole animation. Now we're going to check how this simulation looks, what are the velocities and the temperature, to see how it evolves over time. The great thing about the FumeFX, when you're working with the production size caches that are usually slow to handle, then we can enable draft mode, which will load the grid caches at reduced resolution. So let's go here and enable voxel data display, and we're going to use the display slice and try to make it somewhere at the middle of your data. That's pretty nice. So let's go a bit more further. And right now we can hide the NodeWorks, as we don't need to display particles anymore. Disable smoke, enable temperature to see, and let's increase maximum limit to 250, something like that. Right now it's a little bit blurred because we have enabled emission preprocess, and now there's the real temperature channel that's saved in caches. And you see that temperature evolves nicely with the explosion, and it fades as we set the dissipation. We can now check velocities, as at the beginning we have really strong turbulence noise that creates lots of velocities. As you can see, this is okay only at the beginning stage of an explosion, but later on we really have to lower those values, as this is an artificial noise and it doesn't create really nice and realistic simulation. So it's okay just at the beginning of the explosion, but later on taper it down to 0 values, so let the FumeFX simulation core and vorticity do their job and create beautiful simulations. We're now going to set up the shading. Keep in mind that we are still in draft mode, that affects rendering as well. So keep the shader at the Arnold redshift volume, and we're going to export all the channels like smoke, fire, fuel, temperature, color and velocity. Now we're going to add the Arnold standard volume material to the editor, assigned to FumeFX that is selected, and we'll open up the Arnold render view, go to frame 40 for example, and click activate. Right now we can only see a big box of smoke. That's because our channels are not named properly. So for the smoke, you should type in the smoke. I'm going to increase standstill bit to 10 using the black body shader. We don't have heat, and you should use temperature here, but let's see, for example, if we use smoke here, and for the temperature, for the black body, we really need to use the temperature, and this is the temperature scale from the grid. Higher values will give more brighter fire, and lower values will reduce this brightness. So you see, it doesn't look really good, so we need to use the temperature for the emission as well. And this is something that you would normally do with all the previous FumeFX versions, where you render black body with the temperature channel that's simulated and stored in the caches. However, we have something new with FumeFX 6 that's called Explosion Preprocess. What it does is that it applies blur to the temperature channel. This is the blur width in voxels, and this is the number of times you're going to blur, and each time it blurs, the contribution reduces by a factor of 0.5, which is actually reducing by 2. I already have here our new shader setup. It's the same standard volume, and I'm going to assign to selection here. And as you can see here, I have volume sample RGB. We're sampling the color from the grid and passing to the standard volume as a scattering color. And for the emission here, I'm not using the black body shader, but using a channel, and this is the smoke channel here. We had to ramp up the emission pretty much, as we're not using the black body shader. So the emission color is constructed by using the sample float RGB, which samples the temperature channel from the grid, and it goes from the temperature of 4 to 200 and converts in range from 0 to 1, which is used as this ramp. This is then black at the temperature of 4 and below, and orange is at 200 and above. Everything in between is this gradient, and we pass this to the multiply node, where the second input is the emission mask, which is created in the FumeFX rollout based on the smoke value inside the caches. So this is the minimum smoke value and maximum smoke value. And if, for example, if you increase the maximum smoke value, that will result in a much brighter smoke, as much larger area of the smoke is going to be able to emit light into the volume. So you can completely control and customize this effect to whatever your likings. Here you can see a comparison between different blur widths, and depending on how many blur levels you have in your setup. Now for the final rendering, don't forget that we are in the draft mode. To disable this mode, but of course you can render in a draft mode, some preview rendering to see how it looks. Of course, when disabled, you get full resolution. Now just to mention that for the Arnold renderer, I just isolate one stripe for rendering. I'm using just wave depth of 1, which means 1 bounce of light within the volume, which is some minimum for the effect. Now if you're going to increase this to some really high number, you'll get a bit brighter volume, but rendering is going to take a lot longer to perform. Thank you for watching. I hope you enjoyed this video, and see you soon with more cool video tutorials.